Hey guys, I'm sort of sitting free right now. I'm gonna talk to you all about permutations and permutations when there are indistinguishable objects. Okay. Okay, so basically suppose you have the word cat. So what I want you to think about is how many ways can I arrange the letters in this word to form different sort of arrangements. They are not particularly words, but they are arrangement of the letters from the letter C, A, and T. Okay, so I could have an arrangement like ACT. Okay, that's an arrangement. I could have arrangement ATC. I could have arrangement. What arrangement I could have? I could have arrangement CAT, which is the word itself, and I could have arrangement CTA, and it goes on and on. So, let's derive a formula for doing this. Okay, so you could notice for like if I select C, then I can either go A or I can go T, and from the A I can go to T, and from the T I can go to A. Okay, that's clear. Yeah, that sounds like reasonable. And then from A I can go to C and then go to T, or I can go to A to T to C. That's also reasonable. And then from T I can go to A, then C, and or I can go to C and then A. So if you look deeply enough, you can sort of catch a pattern here. So look, this is like 1, 2, 3, and for this one we have two options, 2, 1 into 2, and then for this one we have again 1 into 2, this one again we have 1 into 2, and for each of these 2's we have 1. Like it could have been like this could have this, and this could have this. Then we would have had again another multiple in our multiplication thing we are doing to capture this. But since we have only one, so we're gonna do one. So if you add up all those 1 into 2 into 1s, you get 1 into 2 into 1 plus 1 into 2 into 1, 1 into 2 into 1. So that'll give you 3 into 2 into 1, because you counted 2 into 1 3 times. Okay, so that is what the formula for permutation is. Basically what happens is you get a factorial. So it whatever n number of things you have, if you want to count all the permutations you can have of arranging those things, you take m factorial. Okay, so free up some space here to talk some more. Okay, so I hope this made sense to you. So here the permutation would be 3 factorial, which is called equal to 3 into 2 into 1. Okay, cool. So now let's talk about something else. What about if I have the word as a word we're all familiar with? It's called mom. Okay, so now if you count the permutations, there could be one permutation like MOM, which is the original permutation. There could be another permutation AOMM. Okay, but If you look at it, if I number these things like 1, and this O can be 2, and this M can be 2, then you can have one permutation where you took the first letter and you took this O, which is 2 only, okay, and you took the second one. And then another permutation, like we are listing all the permutations, you could have this permutation repeat itself, because it could become like M2 O M1. But remember, like, we don't have these numbers, written down. So when we are making our permutations, we would be just counting MOM twice. So how do we capture this in the formula that we have for permutations? So you would be tempted, like, the formula should be 3 factorial. But look, what is happening is, for each permutation that we are listing, like we are listing permutations like MO, M, MO, O, M, M. So for each of these permutations, you have this, wherever you have two M's, that is getting repeated twice, and you can say it into 2 factorial. So because you could, for this permutation, you could have like O M1 M2, or you could have O M2 M1. Basically, this could have been 2 places. This could be filled with 2 things, and here you could have 1. So 2 factorial. So because we are multiplying these permutation twice in our list of permutations, so we are getting double the amount of permutations we actually want. So what is happening is, it's coming out. Okay, the original number of permutations is getting counted 2 factorial times. Okay, 2 factorial times. So we have to divide by 2 factorial, because you have twice, so I need 1 by 2 factorial times. You counted each of the permutations, so I take 1 by 2 factorial to account that into my calculation. So in the permutation formula, you basically then have n factorial by whatever the number is, that the number of indistinguishable objects, like this M and this M, they are indistinguishable. So here it is 2 indistinguishable objects, so divided by the number of indistinguishable objects, factorial of them, because you see, it could have been a bigger. So let's take an example of a bigger word, like institute. So here you could, you have the I, which is, there are 2 I's in my in my word, and there are 1, 2, 3 T's. Okay, so each permutation that I will calculate, like I will okay, I don't have enough. I'll just make some space. Okay, so like each permutation you have, so you will, like this one permutation we had, for the same permutation I could have had I2 here, and S1 T1 and I1 here, and T2 U T3E. I could have like this, as a permutation. So this same thing gets counted twice, and also for this same thing I could also have the T's arranged in a different way. So I could have like T2 here and T3 here, T1 here, and these are captured in the these can be captured by dividing by 1 by 2 factorial into 3 factorial. and the original number that we have in the numerator will be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factorial. So 9 factorial divided by 2 into 3 factorial, which will, I hope you know what the meaning of factorial is, like 9 into 8 into 7 into 6 into 5 into 4, and then we can cancel off the 3 factorial. Will go on like that, and 2 factorial into 3 factorial. So 3 factorial gets cancelled. 2 2 is 2 and 2 factorial is 2 into 1, so we can just cancel 2 and 4, and 4 nines are 36. Okay, 4 nines, okay, sorry, I didn't get included. Okay, 4 nines are 36, and 36 into 7, 5 is 35, 7 6 is 42, 7 to 21, 21 4, 25, 7 9 4 4 9 36, 36 into 7, 6 7 12, 42, 25, 25, 2 into 5, 2, 10, 25, 26, 4, 10, 12, and I think that is, okay, then you multiply it by 6 also, 1260 into 6, 0, 6, 6, 36, 6, 12, 15, 6, 7. Okay, so you have found like 7, 5, 6, 0. It's a lot of permutations. I hope I did the calculation right. I'll just check it on my calculator. Let me see. Well, I hope my calculation skills are not getting that bad. Man, the calculator is taking a long time to load. Yeah, load it on my computer screen. I'm not sharing the computer screen right now, but yeah. So, what did I calculate? 9 factorial divided by 9 factorial. 9. Okay, 9, then factorial. Okay, that, I don't know what happened on my computer. N factorial 9, and then factorial 9 factorial is 3. This. Okay, then divided by. I'll take another bracket. That is 2 factorial. Okay, and into, I'll take another bracket for the 3 factorial. 3 factorial, and what is the answer? This. Okay, I think I should get the same answer. Yes, I think it should be same. The computer is giving me some different answer. I think I didn't calculate it right. I don't know, but whatever. This video was not about the calculations. Well, I think it could be right, it could be wrong. I don't know, but this was more about the concept, idea. So, well, you could do multiplication right and wrong, but you should get the idea right. Okay, so goodbye. Okay, I hope you had a nice time.